Every Monday morning, a little digital miracle happens. Spotify hands me 30 songs I've never heard before. And somehow, I usually love about 27 of them. It's almost creepy. How does an algorithm know my taste better than my own best friend? Better than I know myself? I've been tracking my Discover Weekly for a month now. I've read the engineering papers and I have reverse engineered the system. Here's what I found. It's one of the most elegant AI systems ever built. It's not magic, it's three specific algorithms fighting for your attention. Last week we decoded Netflix, and today we're breaking open the black box of Spotify's recommendation engine. Let's find out how the machine learns what you love. Before we get to the how, you have to understand the massive scale of the problem. Spotify currently hosts over 100 million tracks. If you tried to listen to every song on Spotify, it would take you roughly 600 years. Before Discover Weekly launched in 2015, we suffered from the paradox of choice. You'd open the app, stare at the search bar, and just play the same three albums you listened to in high school. Discover Weekly fixed that by filtering 100 million songs down to the distinct 30 you actually care about. It's currently used by 40 million people. That means every Monday the AI generates over 1.2 billion personalized recommendations. So, how does it sort through the noise? Spotify doesn't use one brain, it uses three. Think of it like a triangle of data. Corner 1 is collaborative filtering. This is the social brain. It looks at what other people like you are listening to. Corner 2 is natural language processing. This is the reading brain. It reads blogs and the internet to see how people describe music. Corner 3 is audio models. This is the listening brain. It actually analyzes the raw audio files. Most recommendation engines only use one of these. Spotify became the king of discovery because they layered all three on top of each other. Let's rip them apart, starting with the most famous one. Collaborative filtering is the backbone of the system. Imagine a giant invisible spreadsheet. On the left, you have 600 million users. On the top, you have 100 million songs. Every time you stream a song, you put a check mark in that cell. Now let's say I listen to Radiohead and the Strokes. The algorithm looks through millions of rows to find other people who also listen to Radiohead and Strokes. It finds user 542. User 542 loves those bands, but they also listen to a band called LCD Sound System. Since our tastes overlap on the first two, the math predicts I will like the third one. It fills the blank spot on my spreadsheet. But here's the catch. Netflix used to have star ratings. Spotify doesn't. So how do they know if you actually like the song? They use implicit feedback. Did you listen to the song for 30 seconds or less? That's a thumbs down. Did you listen to the whole thing? That's a thumbs up. Did you add to a playlist or listen to it 5 times in a row? That is a super like. Spotify weighs these actions differently. A save is worth more points than a stream. They are constantly building a confidence score for every song in that giant spreadsheet. But this system has a major flaw. It's called the cold start problem. Imagine a brand new artist uploads a song today. 0 streams. Collaborative filtering fails here. If no one has listened to it, the spreadsheet has no data. The song is invisible. This is where Engine 2 kicks in. Natural language processing. Spotify's AI crawls the web constantly. It reads music blogs, Rolling Stone articles, Reddit threads, and even descriptions of playlists created by users. It looks for adjectives like dreamy, synth-pop, lo-fi, melancholic. If a blog writes, "This new artist sounds like early Bon Iver mixed with Taylor Swift, the AI knows exactly where to put that song, even if nobody has played it yet. It transforms these words into math. This is called vectorization. Imagine a 3D map. The word heavy and the word metal appear close together. The word acoustic appears far away. Every artist and song get a score based on these terms. Spotify knows that Tame Impala correlates with terms like psychedelic, Australian, and reverb. So when you listen to Tame Impala, the NLP engine scans the database for songs associated with those same keywords. But what if the artist is so new there are no blogs written about them, no streams, no articles? This is where the third and the coolest engine takes over. Engine 3 doesn't care about what people say. It only cares about the raw data. It actually listens to the MP3 files. It uses convolutional neural networks, CNNs. This is the same technology used in facial recognition, but instead of pixels, it looks at audio waveform. It breaks the song down into features like tempo, key, loudness, and even abstract things like danceability and energy. It creates a sonic fingerprint for every track on the platform. Let's look at a real example. If we run Holocene by Bon Iver through this tool, we get the data as acousticness 93%, energy 23%, valence, which means happiness, 35%. Now the AI scans 100 million song database and it finds a track by an unknown artist with acousticness 90%, energy 25%, valence 30%. Boom, it's a match. Spotify can recommend this song to Bon Iver fans purely because it sounds familiar, not because of popularity. This is how indie artists blow up overnight. So we have the social brain, the reading brain, and the listening brain. Every Sunday night, these three engines converge to create your taste profile. Technically, you're just a long strings of numbers in a vector space. Spotify maps your position. You might be deep in the 90s hip-hop cluster, but recently you have been drifting towards modern jazz cluster. The algorithm looks for songs that sit right on the edge of your cluster. It doesn't want to give you what you already know, and it doesn't want to give you something too weird or far edge. It looks for the adjacent possible. The generation process is a massive engineering feat. Because the calculations are so heavy, Spotify doesn't do this in real time. They batch process it. Over the weekend, the servers crunch the numbers. They take your learning history, filter out the songs you have heard before, rank the candidates by confidence score, apply the variety filter. This is important. If the algorithm finds you love Beyoncé, it shouldn't just give you 30 Beyoncé clones. It deliberately forces variety, some rock, some pop, some slow, some fast, to keep the playlist flowing. So, why 30 songs? Why not 100? This is a product design decision, not a tech one. 30 songs is roughly 2 hours, and it's the perfect length for a commute or a morning work session. If they gave you 100 songs, it would feel like work. Also, there is a trust ratio. Usually, Spotify includes 1 or 2 songs you might know. This anchors you. It builds trust, so when they hit you with a weird, obscure track, you're more willing to give it a chance. The genius of this system is that it's a living organism. Every Monday, you are training the AI. If you skip a track in the first 10 seconds, you're punishing the model. You're telling the AI, you messed up. Don't show me this audio pattern again. If you add a song to your chill vibes playlist, you are rewarding the model. This is the reinforcement learning loop. The more you use it, the sharper it gets. That's why your friend's Discover Weekly looks nothing like yours. It has evolved specifically for them. So let's recap the recipe for the perfect playlist. Collaborative filtering finds patterns between users. NLP understands the cultural context and genre. Audio analysis understands the raw sound. They combine these signals to map your taste in a 3D vector space, filter out what you have already heard, and serve it to you in a digestible 30-song package every Monday. It's not just about algorithms, it's about packaging complex math into a simple human experience. This is why it feels like magic. Spotify proved that we don't just want access to all the music in the world, we want a guide to help us navigate it. Next week, we are looking at the most famous AI of all time, ChatGPT. We're going to break down how large language models actually think and why they sometimes hallucinate crazy lies. It's going to be a fun one. If you want to understand the tech shaping your life without the boring jargon, hit that subscribe button. I'm Aradhya, and thanks for watching.